£197,000. The 8T, £18,000. Increase giving 415 mi, 830 kilometers, 520 mi, more range. 110, Airbus. Completed functional and reliability testing. 111. Type certification was awarded by EASA on the 21st of November 2017. 112. Along FAA certification. The first serial unit was on the final assembly line in early December. 113. After its maiden flight on the 7th of December, 2017. Delivery to launch customer Qatar Airways slipped to early 2018. 114. The delay was due to issues with the business class seat installation. 115. It was delivered on the 20th of February 2018. 116. And entered commercial service on Qatar Airways Doha to London Heathrow route on the 24th of February 2018. 117. Possible further stretch. Airbus has explored the possibility of a further stretch offering 45 more seats. 118. A potential 4M stretch would remain within the exit limit of 4 door pairs, and a modest MTO increase from 308T to 319T would need only 3% more thrust, within the Rolls-Royce Trent XWB-97 capabilities, and would allow a 7,600 mi, 14,100 kilometers, 8,700 mi, range to compete with the 777-9's capabilities. 119. This variant was to be a replacement for the 747-400. 120. Tentatively called her 350-8000. 121. 2000. 122, or -1100. 118, at the June 2016 Airbus Innovation Days, Chief Commercial Officer John Lee was concerned about the size of a 400-seat market besides the Boeing 747-8 and 777-9, and Chief Executive Fabrice Bregia feared such an aircraft could cannibalize demand for the -1000. 122. The potential 79M long, 258 feet, aeroplane US competing against a hypothetical 777-10X for Singapore Airlines. 123. At the 2017 Paris Air Show, the concept was shelved for lacking market appeal, and in January 2018 Bregia focused on enhancing the A350-900 /1000 to capture potential before 2022/2023, when it will be possible to stretch the A350 with a new engine generation. 124. Improvements. In October 2017, Airbus was testing extended sharklets, which could offer 114 mi, 185 259 kilometers, 161 mi, extra range and reduce fuel burn by 1.41.6%. 125. The wing twist is being changed for the wider, optimized span load pressure distribution, and will be used for the Singapore Airlines A350-900 ULR in 2018 before spreading to other variants. 126. On the 26th of June, 2018, Iberia was the first to receive the upgraded -900, with a 280T, £620,000 MTO version for an 8,200 mi, 15,200 kilometers, 9,400 mi. Range with 325 passengers in 3 classes. 127, 128. By April 2019, Airbus was testing a hybrid laminar flow control, HLFC, on the leading edge of an A350 prototype vertical stabilizer, with passive suction similar to the boundary layer control on the Boeing 787-9 tail. But unlike the natural laminar flow blade, within the same EU Clean Sky program. 129, on the 30th of September, 2022, a 1.2 T, 2,600 pound, weight reduction and a 3 T, 6,600 pound, tow increase was announced, along with a wider interior cabin to offer 30 additional seats. 130. The interior changes include moving the cockpit wall forward, moving the aft pressure bulkhead one frame further aft and resculpting the side walls to allow 10 abreast 17-inch seats. 131. New engine option. By November 2018, Airbus was hiring in Toulouse and Madrid to develop a re-engined A350neo. Although its launch is not guaranteed, it would be delivered in mid-2020s, after the A321XLR and a stretched A320neo Plus, potentially competing with the Boeing new midsize airplane. Service entry would be determined by ultra-high bypass ratio engine developments pursued by Pratt & Whitney, testing its geared turbofan upgrade, Safran aircraft engines, ground testing a demonstrator from 2021, and Rolls-Royce, targeting a 2025 ultrafan service entry. The production target is a monthly rate of 20 A350neos, up from 10. 132, in November 2019. General Electric was offering an advanced GX1 variant with a bleed air system and improvements from the GE9X, developed for the delayed Boeing 777X, to power a proposed A350neo from the mid-2020s. 133, design. The A350 demonstrator painted like carbon fiber weaves Airbus expected 10% lower airframe maintenance compared with the original A350 design and 14% lower empty seat weight than the Boeing 777. 134. Design freeze for the A350-900 was achieved in December 2008. 135. The airframe is made out of 53% composites, CFRP for the empennage, vertical and horizontal tail planes, the wing, center and outer box, including covers, stringers, and spars, and fuselage, keel beam, rear fuselage, skin, and frame, 19%. Aluminium and aluminium lithium alloy for ribs, floor beams, and gear base, 14% titanium for landing gears, pylons, and attachments, 6% steel, and 8% miscellaneous. 136. The A350's competitor, the Boeing 787, is 50% composites, 20% aluminium, 15% titanium, 10% steel, and 5% other. 137. Fuselage. 9 abreast economy class cabin. The A350 features a new composite fuselage with a constant width from door 1 to door 4, unlike previous Airbus aircraft, to provide maximum usable volume. 138. The double lobe, ovoid, fuselage cross-section has a maximum outer diameter of 5.97 m, 19.6 feet, compared to 5.64 m, 18.5 feet, for the A330/A340. 139. The cabin's internal width is 5.61 m, 18.4 feet, at armrest level compared to 5.49 m, 18.0 feet, in the Boeing 787-140, and 5.87 m, 19.3 feet, in the Boeing 777. It allows for an 8 abreast 242 arrangement in a premium economy layout, B, with the seats being 49.5 centimeters, 19.5 in, wide between 5 centimeter, 2.0 in, wide armrests. Airbus states that the seat will be 1.3 centimeter, 0.5 in, wider than a 787 seat in the equivalent configuration. In the 9 abreast, 333 standard economy layout, the A350 seat will be 45 centimeters, 18 in, wide, 1.27 centimeter, 0.5 in, wider Tana seat in the equivalent layout in the 787, 141, and 3.9 centimeters, 1.5 in, wider than a seat in the equivalent of 330 layout. 142. The current 777 and future derivatives have 1.27 centimeter, 0.5 in, greater seat width than the A350 in a 9 abreast configuration. 143, 144, 145. The 10 abreast seating on the A350 is similar to a 9 abreast configuration on the A330, with a seat width of 41.65 centimeters, 16.4 in. 21, 146. Overall, the A350 gives passengers more headroom, larger overhead storage space, and wider panoramic windows than current Airbus models. The A350 nose section has a configuration derived from the A380 with a forward-mounted nose gear bay and a 6-panel flight-deck windscreen. 147. This differs substantially from the 4-window arrangement in the original design. 148. The new nose, made of aluminium, 149, improves aerodynamics and enables overhead crew rest areas to be installed further forward and eliminate any encroachment in the passenger cabin. The new windscreen has been revised to improve vision by reducing the width of the center post. The upper shell radius of the nose section has been increased. 150. Wing. The Airbus A350's blended winglets. The A350 features new composite wings with a wingspan that is common to the proposed variants. 151. It's 64.75 m, 212.4 feet. Wingspan stays within the same ICAO aerodrome reference code E65M limit as the A330/A340. 152, and the Boeing 777. 153. The A350's wing has a 31.9 degrees sweep angle for a Mach 0.85 cruise speed and has a maximum operating speed of Mach 0.89. 154. The -900 wing covers a 442 square meters, 4,760 square feet, area. 155. This is between the 436.8 square meters, 4,702 square feet, wing of the current Boeing 777-200LR /300 and the 466.8 square meters, 5,025 square feet, wing of the in development Boeing 777X. 156. However, Boeing and Airbus do not use the same measurement. 157. The A350-1000 wing is 22.3 square meters, 240 square feet, larger through a 30 centimeter, 12 in, extension to the inboard sections of the fixed trailing edge. 158. A new trailing edge high lift device has been adopted with an advanced dropped hinge flap similar to that of the A380, which permits the gap between the trailing edge and the flap to be closed with the spoiler. 159. It is a limited morphing wing with adaptive features for continuously optimizing the wing loading to reduce fuel burn. variable camber for longitudinal load control where inboard and outboard flaps deflect together, and differential flaps setting for lateral load control where inboard and outboard flaps deflect differentially. 160. The manufacturer has extensively used computational fluid dynamics and also carried out more than 4,000 hours of low and high-speed wind tunnel testing to refine the aerodynamic design. 161. The final configuration of wing and winglet was achieved for the Maturity Gate 5 on the 17th of December 2008. 162. The wingtip device curves upwards over the final 4.4 m, 14 feet. 138. The wings are produced in the new £400 million, $641 m, 46,000 square meters, 500,000 square feet, North Factory at Airbus Broughton, employing 650 workers, in a specialist facility constructed with £29 million of support from the Welsh Government. 163. Undercarriage. Airbus adopted a new philosophy for the attachment of the A350's main undercarriage as part of the switch to a composite wing structure. Each main undercarriage leg is attached to the rear wing spar forward and to a gear beam aft, which itself is attached to the wing and the fuselage. To help reduce the loads further into the wing, a double side stay configuration has been adopted. This solution resembles the design of the Vickers VC-10. 164. Airbus devised a three-pronged main undercarriage design philosophy encompassing both 4- and 6-wheel bogies to stay within pavement loading limits. The A350-900 has 4-wheel bogies in a 4.1 m, 13 feet, long bay. The higher weight variant, the A350-1000 uses a 6-wheel bogie, with a 4.7 m, 15 feet, undercarriage bay. 165. French-based Messier Doughty provides the main undercarriage for the -900 variant, with titanium forgings from Cabelco. 166. 167, and UTC Aerospace Systems supplies the 1000 variant. The nose gear is supplied by Liebherr Aerospace. 168. The A350-900 has a 4-wheel main gear for a 280 t, 620,000 pound, tow. The A350-900 has a 4-wheel main gear for a 280 t, 620,000 pound, tow. The A350-1000 has a 6-wheel main landing gear to support a 319 t, 703,000 pound, tow. The A350-1000 has a 6-wheel main landing gear to support a 319 t, 703,000 pound, tow. Systems. Honeywell supplies its 1,700 horsepower, 1,300 kilowatts, HGT 1700 auxiliary power unit with 10% greater power density than the TPE 331 from which it I developed, and the air management system, the bleed air, environmental control, cabin pressure control and supplemental cooling systems. 169. Airbus says that new design provides a better cabin atmosphere with 20% humidity, a typical cabin altitude at or below 6,000 feet, 1,800 m, and an airflow management system that adapts cabin airflow to passenger load with draft-free air circulation. 170. The ram air turbine, capable of generating 100 kV, is supplied by Hamilton Sunstrand and located in the lower surface of the fuselage. 171. In light of the 787 Dreamliner battery problems, in February 2013 Airbus decided to revert from lithium-ion to the proven nickel-cadmium technology, although the flight test program will continue with the lithium-ion battery systems. 172, in late 2015, A350 WBMSN. 24 was delivered with 80 kilograms, 176 pound, lighter SAF Li-ion batteries and in June 2017,